Good day once again. Today we are going to continue delivering our class regarding to linear programming. So in our previous class we have seen how to formulate a linear programming by giving some examples in which we have already solved two problems regarding to formulation of linear programming. So our today's topic is graphical solution of linear programming. That is how we are going to solve a linear programming using a graph method. So here is an example given which stated that a man requires 10, 12 and 12 units of chemical A, B and C respectively for his garden. A liquid product contains 5, 2 and 1 unit of A, B, C respectively. So a dry product contains 1, 2 and 4 units of A, B, C respectively per carton. So if the liquid product sell at 3 naira per jar and dry product at 2 naira per carton, how many of each will be purchased in order to minimize the cost and meet the requirement? So this problem we are going to solve is a problem that has stated that a man is managing a kind of garden in which he requires to purchase a kind of chemical. You know, for any chemical, there is a combination of dried and liquid product which are going to be mixed together to form a kind of that chemical. So a man is requiring 5, 2 and 1 unit of these chemicals that include both the dry and the liquid product. So the liquid product is being sold at 3 naira per jar and the dry product is being sold at 2 naira per carton. So our aim is to find how much of each is going to be purchased in order for him to minimize the cost and meet the requirement. So as already been explained that the essence of linear programming is either to minimize the cost and maximize the profit, or to minimize or to maximize the you are going to minimize the cost so that our profit is going to be maximized. So in this problem we are going to minimize the cost so that the product or after we minimize the cost, then definitely definitely there is going to be the requirement is going to be met at the end of the problem. So now we are going to start solving this problem by following our rules. So we are going to write the solution. So the first step to solve this problem is for us to find a solution. So we are to, first of all, we are to find the decision variables. So how do we find our decision variables? So the decision variables here in this problem are the dry product and the liquid product. So now we are going to let X be the number of units of the liquid product. Number of units of the liquid product. And then we should let Y be the number of units of the dry product. So we have let the X be the number of the liquid product, and we have let Y be the number of the dry product. So here are our decision variables. The reason why is that the decision variables are the chemicals, the materials that are going to be utilized for us to form that particular chemical. So we know for any chemical to be made, we are going to mix the liquid and the dry product at the same time. So we have let our X to be the number of units of the what? Liquid product. And we have let Y to be the number of units of the dry product. So now we have already gotten our decision variables. Then the next step, we are now going to find the objective function. So we are to find the objective function. So how do we find the objective function? You see, for any problem given, there must be an objective function for the purpose of solution or solving that particular problem. So in this problem, you can see that we have asked that how many of each will be purchased in order to minimize the cost and meet the requirement. So in this problem, we are asked on how many are going to be purchased. That is, how many of the liquid and the dry product are going to be purchased in order to minimize the cost. So the objective function of this problem, we are going to what? Minimize. Minimize the, which is equals to, how are we going to minimize the liquid and the dry product? So since we have let our X to be the number of units of the liquid product, and in the problem it is being stated that if the liquid product sell at 3 naira per jar, and then we have already let our X to be the number of units of what? Of the liquid per jar. So now we have 3x, then plus, then how many, and then the dry product is being sold at 2 naira per carton. And we have let our Y to be the number of units of the dry product. So now we are going to say that 3x plus 2y, because we have let our X to be the number of units of the dry product, of the liquid product, and then we have let Y to be the number of units of the dry product. So we know that when you add 3 units of the liquid product plus 2 units of the dry product, definitely you are going to have what is being referred as a chemical. Since our objective function we are asked to minimize, then here we have already gotten our objective function. So our aim is to what? To minimize how much of each unit is going to be purchased, both for the liquid and for the dry product. So here is our objective function. So the next thing we should do, we are to find the constraint. I have already told you in the previous examples that the constraints are nothing but what? The operations that have been taking place in the problem. So now, how are we going to find our constraints? So the constraints in this problem are nothing but what? Our chemicals. Then we have our chemicals of what? A, B, and C respectively. So we have chemical A, chemical B, and chemical C respectively. So in the problem, they have stated that we have a man requires 10, 12, and 12 units of chemical A, B, and C respectively. So our constraints are going to be started with the what? With the chemicals. We have chemicals of what? A, B, and C. So here are our what? Chemicals A, B, and C. So what and what are being formed or are being required to that particular chemicals? They have stated that a liquid product contains 5, 2, and 1 unit of what? of this chemical A, B, and C respectively. So, and we have already let our X to be what? Number of units of what? Liquid product. So now, since we have let our X to be the unit of liquid product, and then it has been stated that a liquid product contains 5, 2, and 1 unit of what? A, B, and C. So definitely the chemicals contain what? Each of the liquid product are what? Are been there in the chemical. So in chemical A contains what? 5 units of what? 5 units of liquid product. And then chemical B contains what? 2 units of what? Of a liquid product. And chemical C contains what? 1 unit of what? A liquid product. So we can say that what? 1x. We can leave it as 1, but since we have already let our x to be number of units of liquid, that is why we can what? Set it at 1x. So you see, for the chemicals must contain both liquid and the dry product. So now we have already put our what? Our liquid product here, as is being stated in the problem. Chemical A contains what? 5 units. Chemical V contains 2 units. Chemical C contains 1 unit of both A, B, C respectively. Since we have already put our liquid product, then the next thing we should do is to put our dry product. So how are we going to put our dry product? So remember, we have let Y to be the number of units of the dry product. So, and the value of the dry product is being given as it is being stated in the problem. A dry product contains 1, 2, and 4 units of A, B, C respectively per atom. So now we are going to what? Add them together. So chemical A contains 1 unit of what? Of a dry product. Then we say that plus what? Plus 1y. Then chemical B contains what? 2 units. Then plus 2y. Then chemical C contains 4 units. Then plus what? Plus 4y. So now we have already put the values of both the liquid product and the dry product. And remember, in the problem it's been stated that a man requires 10, 12, and 12 units of chemical A, B, and C respectively for his garden. So that means a man requires 10 plus 1, 5 plus 1 unit of both the dry and the liquid product. Then they must be what? Greater than or equals to 10. This for the chemical A. Then for the chemical D, B must be what? Greater than or equals to 12. Then for the chemical C, must be greater than or equals to 12 respectively. So now we have already gotten our constraint. The constraint I have already told you, that is the operations that has been taking place in any problem. So now we have already formulated. Then for the chemical A should be what? 5x plus 1y must be greater than or equals to what? 10. For the chemical B is what? 2x plus 2y is what? Greater than or equals to 12. Then for the chemical C is 1x plus 4y is greater than or equals to 12. And then remember, non-negativity is what? X and y are greater than or equals to 0. That is non-negativity function. Formulated our problem. Then in general, this can be formulated as mean z, that is our objective function, is equals to 3x plus 2y, then which is subject to our constraint. That is subject to our constraint. Then we are going to what? Stated our constraint, that is 5x plus 1y is greater than or equals to 10. And then 2x plus 2y is greater than or equals to 12. And then 1x plus 4y is greater than or equals to 12. With our non-negativity, x and y must be greater than or equals to 0. So, in general, our problem can be formulated as that, as this. So, the next thing we should do, we are going to remember this is called inequality equation. So, we are going to make it to be in standard form, that is in real equation. So, convert the problem into standard form by saying min z is equals to 3x plus 2y, which is subject to 5x plus 1y is equals to 10. We call this as what? Equation 1. Then 2x plus 2y is equals to 12. We call this as equation 2. Then 1x plus 4y, which is equals to 12. We call this to be what? Equation 3. With our x and y are greater than or equals to 0. So we make it, we have converted it into standard form. That is, min z is equals to 3x plus 2y, which is subject to 5x plus y or plus 1y is equals to 10. We call it as equation 1. Then 2x plus 2y, which is equals to 12, we call it as what? Equation 2. Then 1x plus 4y is equals to 12. We call it as what? Equation 3, with our x and y are greater than or equals to 0. Solve this problem by taking each equation and make x and y to be subject of the formula. Then we are going to start from equation 1. Equation 1, which is what? 5x plus 1y, which is equals to 10. So now, we are going to solve for x when y is equals to 0. That means we are going to make x to be subject of the formula. So, solve for x when y is equals to 0 in equation 1. So now, we are going to say that 5, we are now make x to be what? Subject of the formula. Then, we are going to say that 5x plus 1 into 0, that is, we have made y to be equals to 0. Then we are going to represent the value of y in this equation to be equals to what? 0, which is equals to 10. So you know, anything multiplied by 0 is gone. Now we have 5x, which is equals to what? 10. So for us to have the value of x here, we have to divide both sides by what? By 5. 5 go with 5. 5 here, 1, 5 here, 2. So the value of x here is equals to 2. Then solve for y when x is equals to 0 in this equation also. So we are now represent the value of x to be equals to 0 in equation 1. Then in equation 1 we have 5x. We are going to what? Represent the place where x appears to be equals to what? 0. So 5 into 0, 5 into 0 plus 1y, which is equals to what? 10. So 5 times 0 is 0. Then y, 1y and y are all the same thing. So y is equals to what? Y is equals to 10. So now the value of x and y in equation 1. We have value of x is equals to what? Is equals to 2. Then the value of y is equals to what? Is equals to 10. In which equation? In equation 1. So we have gotten both the value of x and the value of y in equation 1. In equation 1. So we are going to do the same thing for both equation 2 and equation 3. Then from equation 2, equation 2 stated that 2x plus 2y is equals to 12. Then we have 2x plus 2y is equals to 12. Then we are going to do the same thing as we have did in equation 1. We are going to solve for x when y is equals to 0. Then we are going to represent the value of y to be equals to 0 in which equation? In equation 2. So in equation 2 stated that 2x plus 2, then y is equals to what? Is equals to 0, which is equals to what? 12. Then 2 times 0 is gone. We have 2x, which is equals to what? 12. To have the value of x now, we are to what? Divide both sides by the coefficient of x. 2 here, 1, 2 here, 6. So the value of x here is equals to 6. Then we are to what? We are to solve for y when x is equals to 0. So we are going to represent the value of x to be equals to 0 in what? In equation 2. So we have 2 into 0 plus 2y, which is equals to 12. So this is gone because 2 times 0 is 0. Then we have 2y, which is equals to 12. So to have the value of y, we are to what? Divide both sides by the coefficient of the y, which is what? The coefficient of the y is equals to 2. Then we are going to divide both sides by 2. 2 go with 2. So y is also equals to 6. So the value of x and y in which equation? In equation 2 are x is equals to 6 and y is also equals to 6. So value of x and y in equation 2 are 6 and 6 also. Then we are going to do the same thing for the last equation, which is equation 3. So from equation 3 stated that 1x plus 4y is equals to 12. So equation 3 is 1x plus 4y is equals to 12. So we are going to solve for x when y is equals to 0 in this equation. So 1x or only x is all the same thing, but for the purpose of fully understanding, we are to put it as the way it appears in the equation. So 1x plus 4 into 0 is equals to 12. Here is gone. So 1x as x is all the same thing. X is equals to 12. Then we are to solve for y when x is equals to 0. Then we can just say that 1 into 0 plus 4y is equals to 12. Then here it's already 1. Then we have 4y is equals to what? 12. Divide both sides by the coefficient of y to get the value of y. So 4 go with 4, y is equals to 3. 4 into 4 is 1, 4 into 12 is 3. So y is equals to 3. So the value of x and y in equation 3, we have x is equals to 12 and y is equals to 3. So we have already gotten the values of x and y in all the three equations. Remember, in equation 1, we have got the value of x is equals to 2 and the value of y is equals to 10. In equation 2, we have the value of x is equals to 6 and the value of y is equals to c. Then in the last equation, which is equation 3, we have the value of x, which is equals to 12, and the value of y, which is equals to 3. So the next step is that we are going to use the values of x and y to plot our graph. So we are going to use the values of the equations for us to plot our graph. So since we have the highest number in x is 12 and the highest number in the y values is 10. So maybe we are going to use 2 centimeter to represent 1 unit in both the x and the y angles. So let us write or plot our graph. So here is our x axis and this is our y axis. So we are going to use the values of the equations for both the y and the for the x and y to plot our graph here. Remember, we have used 2 centimeters to represent 1 unit. This is the reason why you see it started from 2, 4, 6 up to 16 for x axis and from 2 up to 14 in the y axis. So now from the equation 1, the value when x is 2, y is 10. So here is the x axis. So when x is 2 here, then y is 10. So y is somewhere in this place. So we are going to merge them together. So maybe we are going to use this as our ruler for us to merge them together. So we finish for the equation 1. Then for the equation 2, when x is 6, y is also 6. So when x is 6, y is also 6. Then we are going to merge them together also. And then the last equation, when x is 12, y is equals to 3. So when x is 12, then y is equals to 3. So since we don't have 3, so 3 falls somewhere around this place. Then we are going to merge them together. So now we have plotted our graph, as you can see. Then we can write both the equations. So equation 1, what is the value of the equation 1? The next thing we are going to find is our own corner point. That is where the x and the y merge together. So the corner point, we have already one here. X is 0 and y is 10. We have a point here. and we have here as our what? As our B, and then we have this place, our C, and then we have y is equals to 0, x is equals to 12 as our what? As our D. That is the corner point. So we are to put the equations for the equation 1, equation 2, and also the equation 3. So equation 1 is 5x plus y is greater than or equals to 10. This is equation 1. Then for the equation 2 is what? 2x plus 2y is greater than or equals to 12. And the last equation is what? X plus 4y is greater than or equals to 12 also. So some of you are going to ask, where or how do we find our corner point? So the corner point are nothing but what? Where the x and y meet together. So the places where the x and y being attached together is what refers as the corner point. So here, if you can see that here is what? X, and here is the y-axis. So they meet together at this place, so that we have gotten our corner point E. And also this place, x is here and y what is here. Then they also meet together in this place. We have our corner point B. And then the last one, the y is here and also the x is here. They meet together in this place. We have gotten our what? Our corner point C. Then the last point is D, where x is here and what? Y is also in this place. Then we have already gotten our corner point A, B, C, and D. So we are going to write them. The corner point we have A, B, C, and D. So we are going to what? Put the values of x and y of the what? Of the corner point. So when x is 0, the y is what? Is 10 in equation 1. That is in the place they have made together. So x is 0, y is 10. Then for the corner point B, so what is the value of x and y? Then we are going to what? Have something here, so that we are going to have the exact value for both the x and the y. So here we can assume that the value of x is 1.8 or 7. Let's say we are going to take it as 1.7, and the value of y is 5, let's say 0.6 or 0.5. Then let's assume to take it as 5.6. So the value of x is 1.7, and the value of y is 5.6. Then for the corner point C, we are going to do the same thing. So the value of x in corner point C is what? The value of x is fall at 4. So x is equals to 4. Then y is what? 2 point, let's say 2 or 1. Let's assume to take it as 2.1. Then y is 2.1. Then for the last one, x is equals to y is equals to 0 and x is equals to 12. So x is 12 and y is equals to 0. So the next thing we are going to do is that we are going to use the value of the corner point to test the optimal solution. That is to test which value are we going to select for the gardener to minimize the cost of the production or the cost of the purchase of his chemicals. So remember, our mean Z is equals to what? 3x plus 2y. So we are going to test the objective function to this value of the corner point. So you see, we are going to what? Test whether 3x plus 4y favors the corner point, so that we are going to have the exact or the minimum number, because we have been asked to minimize. So the first one is that 3. Then we are going to what? Put the value of both the x and the y in all the corner points. So let's begin with the corner point A. Corner point A, we have the value of x to be equals to 0 and the value of y to be equals to 10. Then our main Z is what? 3x. Then the value of x here is what? Is 0 plus 2y. The value of y here is what? Is 10. So 3 times 0 is 0. Then 2 times 10 is equals to what? Is equals to 20. Then we are going to do the same thing as the corner point B. Then 3 into the what? Value of x is what? 1.7 plus 2 times what? 5.6. Then for the what? For the corner point C, we are going to have 3 into 4 plus 2 into 2.1. And then for the last one, we have 3 into 12 plus 2 into 0. So 1.7 plus 2 into 5.6 is equals to 16.3. And also 3 times 4, which is equals to 12, plus 2 times 2.1, we are going to have 16.2. Then the last one, you see, anything times 0 is 0. Then 3 times 12 is equals to 36. So we have gotten the values of x and y in all the corner points. So the next thing we should consider is that, remember, since from the beginning, our objective function is to minimize the cost. So in this value we have gotten, then we are going to look at the values to select the one which is the most minimum in all the values we have gotten. So the most minimum here is what? Is 16.2. 16.2 is the most minimum one. So therefore, 16.2 is our final answer, because whenever the gardener wanted to minimize the cost, he is going to purchase 4 units of liquid product and is going to purchase 2.1 unit of the dry product for him to have the minimum cost of what? 16.2. So therefore, 16.2 is our final answer.